Don't forget to check out the resources in the Pre-Cal Trig I Can. You can find the I Can in the course content under resources. So make sure that you know where this is. You can also find helpful videos and a lot of resources to answer questions that you may not be able to find in the course, or if I'm not available, you can look at this and find resources that will help you on your own. You should have joined Quizlet, and each week prior to class, you should be studying the vocabulary and coming to class prepared to use that vocabulary. So when you're looking at these graphs, I'm looking at end behavior. If I look at the first one, this will start, the graph is going down in the third quadrant and up in the first quadrant. This is a type of graph with an odd degree. So if you put your polynomial in standard form, the leading term, the highest power, is going to be odd. And it's going to be positive. If we have an odd degree and a negative leading coefficient, this is going to switch. And so it would be going down in the fourth quadrant and up in the second quadrant. All right, so we can tell from this graph that it is of odd degree and the leading coefficient is positive. For the second one, the end behavior is showing that the graph goes up in the first quadrant and also up in the second quadrant. Now, this is not a quadratic equation because it's not a parabola. Something else is happening in the middle. So it could be a quartic. It could be of degree 4 or 6 or 8, but it is an even degree function. Now, what happens whenever the leading coefficient is negative, then this will just flip upside down, and then it will be going down in the third quadrant and down in the fourth quadrant. All right, what do we notice about this one? This one looks similar. The third one looks similar to the first graph, except now it's going up in the second quadrant and down in the fourth quadrant. Now, would that be what we talked about earlier of having a leading coefficient being negative? Look at that for a minute and think about it. Okay, if the leading coefficient is negative, we said it's going to be going down in this quadrant, in the fourth quadrant, and up in the second quadrant. So it is going down in the fourth quadrant and up in the second quadrant. So this is a graph where the leading term, the highest power term, is odd, but the leading coefficient is negative. Leading coefficient here is positive. If it's negative, it would be going down, but this is even, this is odd, this is odd. Now this one looks similar to this first and third, but I'm going to use the vertical line test. So if I draw a vertical line and it only touches one point, then I have a function. Now it works in 1, 2, and 3. But the vertical line test does not work here. So this intersects at 1, 2, 3 points, so this is not a function. This one does not belong. Okay, on Monday, you should be doing the review. Go into the course. I cannot reiterate this or stress this enough because a lot of you are just working off of the due dates. That can cause some confusion and you will miss taking notes if you do not go into the course daily for 30 to 60 minutes. But on the 19th, there's a lot here. It's covering all of Unit 1 and there's practice and there's room to take notes and also to plan to come in for help if you need help throughout the week. On Friday, if you do not see what you think you should see in the gradebook, come in and visit with me. Come in during on Thursday during office hours at 10 a.m. or on Monday, the following Monday at 10 a.m. Or schedule a help session on Tuesday, Wednesday, or Thursday. All right, you should be taking notes all along because at the end of each unit, you can turn in your notes for extra credit. It's only a 2-week window after that test is due. So 2 weeks from September 21st is going to be the last day that I accept any notes. All right, the part twos, you can redo those as many times as you want. Look at my feedback before you make corrections. Maybe you just turned in the wrong assignment. That happens a lot when students get in a hurry. So you can quickly remedy that, turn it in for full credit. All right, we're going to start with question number 1, and we're going to work through this. Look at how the multiplicity of a 0 determines the behavior of the graph at that 0. So we're given in words, we're not given a picture of the graph. We're not given a function in factored form. We're simply given a set of words. So we're going to take these words and we're going to interpret what they're saying in English back into math. All right, so this is a little bit tricky, not that you can't do it, okay? So notes, use your notes during the test. But if you're going to copy and paste answers, it's really going to slow you down a lot. So let's just look at what it says. It's a 7th degree polynomial. So I'm just going to write an example. It could be x to the 7th power. That's all I know. If we write it in standard form, this is going to be our first term. Okay, we don't know what that leading coefficient is, but we do know that it's x to the 7th power. So in this function, it has zeros. Zeros, we also call them roots, and we also call them solutions. We have a 0 of -5. Okay, so let me write that down. That would be x. If we write down x equals -5, that would be where it touches or crosses the graph. Now, if we move this -5 over to the left by adding 5 to both sides, we have x plus 5 equals 0. That will be one of our factors. If we're factoring a polynomial or a function, everything would be on the left, and we would factor it, and then we would use each factor to find a solution of where the x value is. All right, we also have 0, so it's going to cross the x-axis at 0. So that would be x plus 0 or x minus 0. It doesn't matter because 0 is neutral, with a multiplicity of 2. So that's the power of that root. Okay, we also have 1, so we've taken care of that. We also have a 0 at 3. So this is just going to be just like x equals -5. We're going to write this as x equals +3. And then we would subtract 3 from both sides and write that factor here. Let me move this out of the way or just scratch through it. Another factor would be x minus 3. Okay, now this doesn't tell us a multiplicity. And when a multiplicity is not stated, it is to the first power. I'm just going to go ahead and write it so that you can see it, but normally we don't write it. So we have a root here at x minus 3 or at x equal 3 to the first power. All right, let's move on to 4. So again, x would equal to 4. Think about that. If you subtract 4 from both sides, you get x minus 4 equal 0. So x minus 4 is that binomial that goes over here on the left. And if we multiplied all that out, oh, I forgot something. Multiplicity of 3, I'm getting too big of a hurry, so slow down on all of this. So this is x minus 4 to the 3rd power. So let's see, let's add all those up. 1, 2, 3, 4, 5, 6, 7. So I'm just checking to make sure that I did all that right. Yes, it is a 7th degree polynomial. If we multiplied it all out, we would have a function that met all of those requirements. So now let's put this into words. The graph of this function does what? So here are our answer choices. Right here, our answer choices we choose from. Does it cross through, straight through, like the equation of a line, without any kind of movement or wiggling? Is it tangent to? Now, we're bringing that up to the word tangent, where in the past you might have used hugs, and we'll still use that transition to the word tangent. Tangent means it's going to touch and then bounce in the opposite direction. Crossing straight through is a multiplicity of 1. Tangent is an even multiplicity. It can be a quadratic equation, x squared. It can be an equation, a quartic to the 4th power. Any even numbered function is going to touch the x-axis and bounce in the opposite direction. Whatever direction it's approaching from, if it's approaching from below, it's going to hit the x-axis and bounce in the opposite direction. If it's approaching from above, it's going to hit and bounce back up. All right, now the crosses through while hugging is anything that's odd and it's greater than 1. So a function to the 3rd degree, instead of just going, let's go ahead and just sketch the x-axis. Instead of going straight through the x-axis, it would approach and then get close to, almost like an asymptote, and then go through. All right, so let's interpret that. All right, at the x-axis, what happens at the solution or the root -5? -5 has a multiplicity of 1, so it's going to go straight through. I'm going to take that and move it up here. All right, now the graph of the function, let's go to the 2nd line, at 0. So what happens at 0? 0 has a multiplicity of 2. In fact, we would drop the 0 and just write x squared. Okay, so anytime you see something without plus or minus as a factor, one of those binomial factors, if it's just an x without any constant being added to it, it's still going to be, the root's going to be at 0, and then that multiplicity is going to be whatever that exponent is. All right, so this is an even number, so it's going to be tangent to. So let's take that and move it up here. Now we're going to go to where we have a solution at 3. So that would be right here. And this is to the 1st power. So this again is going to cross straight through. Now let's look at the x-axis at 4. If we look at 4, it has a multiplicity of 3. So that's going to cross through while hugging. All right, again, use your notes. Make sure that, especially the end behavior notes that I gave you in the I Can, you need to find those and utilize those during the test. All right, question number 2. Number 2 says, what is the solution to the rational inequality? 5x over x minus 3 is less than or equal to 2 over x minus 3. Now I'll look at those, and it doesn't have an equal sign. It has a less than or equal sign. That's what gives us the inequality. So we've got to be careful with inequalities, because one of the things that you should remember is that if you multiply through by a negative, then the sign is going to change direction. So we can't multiply through by x minus 3 on both sides because we don't know what x is. If x is, let's say x is 1, then that would be multiplying through by negative, but we don't know what x is. So we can't do that, so that's out. Okay, so what I'm going to do is I'm going to subtract this from both sides. So let me go ahead and move it down. 5x over x minus 3 minus 2 over x minus 3. I'm subtracting that term from both sides. And when I subtract it from this side, this is going to turn into 0. So I can say less than or equal to 0. All right, now we look and I have a common denominator. So I can combine the numerators, 5x minus 2 over x minus 3 is less than or equal to 0. Now we've simplified this so that we can evaluate it. Now, once we've moved everything to one side and we've simplified, adding or subtracting like terms, then I can look at points of interest. So the first thing I'm going to look at is x minus 3. When x minus 3 is equal to 0, we're going to have a hole in our function or an asymptote. In other words, there's not going to be a solution of any kind at x minus 3. So add 3 to both sides and solve, and you'll get x equals 3. So on the x-axis at 3, this is 0 and this is 3, you're going to have to put a circle there if you're asked to graph it. So I'm going to put that as reference, knowing that we've got an open hole right there. Now let's evaluate the numerator. 5x minus 2. Now when that's equal to 0, we have a solution. Okay, because when that's equal to 0, yes, that would be less than or equal to 0. All right, so I'm going to solve by adding 2 to both sides. So when you add 2 to both sides, you get 5x is, I forgot to put the less than or equal to, 5x, this is going to become 0, is less than or equal to, adding 2 to both sides, less than or equal to 2. The last step is to divide by 5. Now, if we're dividing by a positive 5, be very careful that you pay attention to your signs. Dividing by a positive 5 does not change direction, and we get x is less than or equal to 2/5. So I have another point of reference. Now look at this closely. This says less than or equal to. The equal to means that we're going to shade this in at 2/5. So it's not going to be somewhere here. I didn't draw this big enough, but I'll just say this is 2/5 and we'll shade it in. So we have a point of reference here. Now all these other points, I'm going to change my pen color so it doesn't get too distracting for you. Hold on. I'll change it to red. We're going to look at these areas. So I'm going to section it off into 3 areas and use these points that I put on the graph. And I'm going to call this area 1, area 2, and area 3. And we're going to pick a point from those 3 areas, substitute it back into our inequality, and then we're going to check to see if we have a solution. Let me erase some of these things up at the top so that we can look at that and plug those values back in. All right, work through this slowly and carefully because it's so easy to make mistakes, especially with those negatives. Well, I'm going to start in area 1, and I'm going to go ahead and take care of that 0 because that's going to be easy to multiply 0 to 5. We get 0. 0 minus 3 is negative 3, but it doesn't matter what is in the denominator. 0 over anything is 0. All right, so we've simplified the left pretty easily. All right, now we're going to look at the right-hand side. 0 minus 3 is negative 3. So we have Positive 2 over negative 3, that's negative 2/3. Now we're going to evaluate whether this statement is true. Is 0, let's look at 0. It's right here. Is 0 equal to, less than or equal to negative 2/3? Well, negative 2/3 is going to be somewhere over here. And 0 is not less than or equal to negative 2/3, so no. We have to evaluate all three of these areas, so don't work through this too quickly. All right, let's go here to section number 2. Find a number between 2/5 and 3. And there's an easy one that I'm going to pick. You can pick any number, but one that's going to be easy for me to work through is picking the number 1. So let me erase this, and we'll go in and we'll evaluate what this is when we plug in the number 1. All right, so 1 times 5 is 5. 1 minus 3 is negative 2. So we have 5 on the top and negative 2 on the bottom. Okay, now we're going to see if that's less than or equal to 2 over, remember what we're putting in here, we're putting in a 1. 1 minus 3 is negative 2. All right, simplify that and we get negative 1. So we're going to ask ourselves, is negative 5/2 less than or equal to negative 1? Well, what is negative 5/2? 2 goes into 5 2 times with one remainder, 2.5 or 2 1/2. Is negative 2 1/2 less than 1? And the answer is yes. So this middle area is everything in between, from here to here, will contain solutions. Now there's one more place to check. Everything bigger than 3. So let's pick something easy. I'm going to pick 5. It's just a personal preference. Doesn't matter. If you've got a calculator, that's going to come in really handy. All right, so I'm going to take 5. Let me erase this, and we'll go back and we'll work on that again. All right. All right, 5 times 5, the numerator is 25. Over 5 minus 3, the denominator is 2. Less than or equal to. I'm just going to double check to make sure I did that right. All right, and then move to the right. We have 2. We don't have anything to simplify in the numerator. The denominator, remember what you're substituting in. 5 minus 3 is 2. So let's simplify that. All right, 2 goes into 25, 14 1/2 times. Is 14 1/2 less than or equal to 1? And the answer is no. So our solution, all of our solutions are in between 2/5 and 3. So we're asked to write that in set notation. So let me clear this up. Let me erase a little bit, and we're going to write our answer in set notation. All right. A couple of people have reported to me that they're using the U for the union symbol. Don't use your keyboard to type in the union symbol. Use the computer and the tools that are on the computer, or you'll have to talk to me and point out what's happening. Don't make that mistake. Let's learn to use the tools that are in the course. All right, so again, let's look down here. Let me change my pen color one more time to help not get too confused here. I'll change it to purple. All right, so we're going to start at, this is what we're looking at, 2/5. So we're starting at 2/5. Are we including 2/5? Well, we colored it in. So yes, that's part of our solution. We would use a hard bracket. Okay, and then I'm going to put a comma which means in set notation from 2/5 to the number 3 and everything in between. But we're not going to include 3, so we use a soft bracket. It's almost like drawing a circle or that open hole right there. We don't want to forget that that's where we have a hole or an asymptote. Okay, so this is our solution. Now let's move on to question number 3. What two rational expressions sum to 3x plus 2 over x squared minus 3x minus 10? I've already been asked this a lot, and I understand because if you're not going into the course, which is our online textbook, if you're only working in your plan, you're going to miss the practice that goes along with this. So that's we want to correct that right now before we go any further and it slows you down. But let me go through the steps. Where would we start? We're going to factor both the numerator and the denominator. Look at the numerator first. There's nothing to factor, so we're just going to write that as 3x plus 2. Now let's look at the denominator. The denominator is a trinomial, and there are some tools that I've given you in the ICAN that can help you do this quickly. I'm not expecting that you do the grunt work that you did in Algebra 2. You really hope, I know if you were in TOPS, you had a really good teacher that taught you and gave you lots of practice to help you master this. If you're coming in from another school, I'm not sure how you learned how to do this, but this is not Algebra 2. We're done with that. We're moving on to pre-cal. So I am allowing you to use calculators, and there are plenty, but just don't go and ask somebody to do the work for you. All right, I'm going to go ahead and show you because this is relatively simple. I'm going to factor -10. I'll put it in a T-chart and come up with two factors that add to this middle term, -3. Well, I've got 1 times 10. And if you make one positive and one negative, they do multiply to give you -10, but they don't add together to give you -3. So now I'm going to choose 2 and 5 and make one of those negative. I'll make the 5 negative. And then when you add those together, I do get that middle term, what I'm looking for. So this is how I factor this into two binomials, x plus 2 times x minus 5. And then just double check to make sure that you do have the right terms, binomials. You can FOIL it out. Take the first term, x squared, outer and inner, -5 plus 2 is -3x, and then the last term, -5 times +2 is -10. So yes, that does check out. All right, so we factored the bottom into x plus 2 times x minus 5. All right, so the roots are 5 and -2. Set each of these equal to 0 and solve. All right, now we're going to start. Let me go ahead and erase that. That was just an observation here. Okay, we're going to take those two factors and we're going to put them into two smaller fractions. One with the denominator x plus 2 and one with the denominator x minus 5. We're going to add those together to get, I won't rewrite this, but add those together to get this. Maybe I should rewrite it. Let me go ahead and, I just don't trust my mouse skills, but let me go slow. 3x plus 2 over x squared minus 3x minus 10. Let me erase some of that. It's kind of running into each other. So we do not get confused here. done all the factoring. Again, you can even use the MathPapa factoring calculator or a calculator of your own to do the factoring for you. All right, so we've got it broken into two pieces, but we don't know what the numerators are. That's what we're trying to find. All right, so I'm going to use just the capital letter A. The reason I'm using a capital letter is because this could be a single term, or it could be a binomial, or we don't know what it is. It could be complex. So I'm going to use the capital letters A and capital letters B. Let me see, I didn't erase that x squared over here. All right. All right, next, we know, let's go back to what I erased. We know that one root is x equals -2, and I know another root or solution is x equals 5. Looking at these two things here. Okay, so what I'm going to do is I'm going to start out with one of these. So I'll just start out with the -2 and I'll plug it in to the equation everywhere there's an x. But before I do that, let me change my pen color. Before I do that, we're going to multiply through every term by x plus 2 times x minus 5, because if we multiply those together, we get this, the least common denominator. Okay, so we're going to be multiplying this through by x plus 2, x minus 5, which will just cancel this out, because if we multiply those out, that's where we got that in the first place. We factored that. Then if I multiply this term, okay, the x minus 5 cancels, and we're left with b times x plus 2. Let me go ahead and write on the right side, we were left with 3x plus 2 on the top. The denominator canceled out because we're trying to simplify. That's our goal. All right, now we're going to take the x plus 2 times x minus 5, multiply it to this term. So the x plus 2 will cancel out, and we're left with x minus 5. So this first term is a times x minus 5. Simply simplifying. Okay, now we're going to take this first term, this x minus 2, and we're going to plug it in everywhere there's an x. So we'll put a minus 2 here, a minus 2 here, and a minus 2 here, and simplify. -2 minus 5 is -7. -7 times a, we still don't know what that is -7a. Plus -2 plus 2 is 0, and 0 times b is 0. So we don't have to put anything there. I'm just going to go ahead and erase that. All right, starting to look a lot nicer now. Move over to the right-hand side. 3 times -2 is -6 times x plus 2. Wait a minute. There's no x there. That's what -2 is. This is just -6 plus 2. So -7a is equal to 3 times -2 is -6 plus +2 is -4. Divide both sides by -7. And you get a is equal to, a negative divided by a negative is a positive, 4/7. So we have solved and we have gotten a solution for a. Now let's move on and do the same thing for x minus 5 or x equals 5. We're going to substitute in 5 for x this time. So let me just write it over the x. Oops. Let me back up and erase that. We want to simplify this first. So let's just go through all of what we did before. All right, let me get my pen. And we're going to multiply each term times the least common denominator. So let's start here. We know that this cancels out, and we're just left with 3x plus 2. Move over to the left, take the x plus 2 times the x minus 5. The x minus 5 will cancel out, and we have b times x minus 5. We're repeating what we did earlier to simplify this before we start. All right, multiply here, and the x plus 2 cancels, and we're left with the x minus 5. So we have a times x minus 5 plus. All right, I'm getting better with the mouse, but not great. Now we're going to take the 5, we already put the negative 2 in there, and we're going to substitute it in everywhere there's an x. So this is 5 minus 5 is 0. 0 times a is 0. So this is going to go away. You just put an x through that. Oh, I'm sorry, darn. I am in too big of a rush. This is a times x minus 5. And look here, the x minus 5 cancel. We're left with x. This should be plus 2. This kind of threw me off. All right, so again, put a 5 in here. 5 minus 5 is 0. 0 times anything is 0. So just move on to the second term. Put a 5 in here. 5 plus 2 is 7. So we have 7 times b. Move over to the right. Put a 5 here. 5 times 3 is 15 plus 2 is 17. Divide both sides by 7, and b is equal to 17 over 7. So we've got a and we've got b. So let's put this into our answer. Let me erase, and we'll write our answer out. Now this is going to be tricky. Make sure that you got all your signs correct, and we'll have a fraction that goes in the computer a certain way. If you find out that the computer is not grading what you intended, reach out and let me know, and we'll clear that up, okay? But don't go and rush and take your second attempt before we clear up any misunderstandings. All right, so b is 17 over 7. So we're going to put that right here. 17 over 7 times 1 over x minus 5 is equal to 17 over 7 times x minus 5. Okay. This is taking a little bit longer because I don't have a lot of room on the board. So that's the second term that we're going to be adding. I'm going to erase as we go. That first term is going to be, we replace a with 4/7. So basically the 4 goes with the numerator and the 7 goes with the denominator. So it's 4 over 7 times x plus 2. Okay, and these are the two pieces that add together to give us this expression. All right, now that took a little bit. Not all of these are going to take quite so long. Let's move on to the next one. Question number 4. What is the upper bound of the function? Now this one, there are a lot of pieces that we did that come together for this one. So let's just take a minute and look at how to work this out. The first thing that we're going to do is we're going to take our constant and we're going to factor it. Now we refer to this as p. We put our p's over our q's. And then we're going to take our leading term, because this is in standard form, and that's what we're going to call our q, and we're going to factor our p. So we're going to take -3. The factors of -3 are 1 and -3 and -1 and 3. So plus or minus 1 and plus or minus 3. Now we're going to take the factors of 2. Factors of 2 are 1 and 2, plus or minus. Now what I do, is just my preference, is I just look at the positive numbers, and then when I'm done, I put them together with the plus or minus symbol to make all the possible factors. All right, so we're going to put our p's over our q's. All the factors of that constant are 1 and 3. And if you remember my hint, what I do to speed things up is I just look at the positive terms, and at the end I put the positive and negative symbol. All right, we're going to pair those up with all the factors of the q's. So 1 over 1 and 1 over 2. Okay, and then I'm going to go to the factors of -3. And again, I'm only looking at the positives. 3 over 1, put them over the factors of 2. 3 over 2. Simplify, we cannot reduce 1/2, so I have positive or negative 1/2. 1 over 1 is 1, positive or negative 1. 3 over 1 is 3, positive or negative 3. And positive or negative 3/2. Those are all the possible factors. Now I'm going to apply synthetic division, and what I'm going to do is I want the upper bound, so I'm looking only at the positive solutions. So I'm going to move on to the next slide and show my work here. Now remember, these are all my possible factors. So I'm going to just start with, I can plug 0 in there, and I can show you that starting with 1 is just going to be the quicker way to do this. So to save some time, we're going to use synthetic division. Put 1 outside of that upside down division symbol, and this is the same function. Go ahead and take the coefficients. We've got positive 2. Let's see if we're missing any terms. X to the 4th, x to the 3rd. We're missing an x squared. Let's don't forget to put a 0 in there. And then we'll have everything. All right, so we've got a 2, -7, 0, -35, and -3. All right, we start by bringing down that first term. We bring down the 2, and then we multiply 1 times 2 is 2. We put it up here. We combine these two terms, and immediately we get a negative number. So this is not the upper bound. So now I'm going to move up. I'm going to erase that 1, and I'm going to go up to 2. Okay, we always bring that 2 down. So I'm going to start with 2 times 2 is 4. Okay, put a 4 here, subtract or add -7, we get -3. So 2 doesn't work. So I'm going to go up to, guess what the next number is? I'm going to go up to 3, bring down that 2. 3 times 2 is 6. 6 plus -7 is -1. So that's still not working. Let me erase this. Okay, we always bring that 2 down, that first term. So now I'm going to try 4. 4 times 2 is 8. Now this time, I'm going to get a positive 1. Keep going. 4 times 1 is 4. Add that to the 0. We still get a positive number. And then 4 times 4 is 16. 16 plus 35, we're going to get a negative number. Okay, so I'm going to go up to 5. I was getting all excited there. All right, let's go up to 5. All right, bring down the 2. 5 times 2, I didn't erase enough, is 10. All right, 10 plus negative 7 is a positive 3. 5 times 3 is 15. Add that to 0, bring it down. And then here, we're going to get a number that's bigger than 35. That's going to be a very big number. You can go ahead and do it on your calculator. I don't have mine with me. Oh, yes, I do. Here it is. It's always good to use your calculator. So 5 times 15 is equal to 75. 75 take away 35 is equal to 40. So put that 40 down here. And then 5 times 40 is 200. And when we add that to the negative 3, we do get a positive. So this is going to be our upper bound of the function. All right, solve this equation. Okay, I'm going to look at this and see if there's any simplifying that I can do. I have a radical on the left and I have a radical on the right. And we need to get rid of the radicals. We need to undo them before we start solving this equation. So what I'm going to do is if I put both of these radicals on the same side and I square, then I'm going to end up with a very complicated mess. So let's just square the left-hand side. Okay. And then I'm going to square the right-hand side. If I can get my pen, hold on. All right, so this is the left-hand side. We have two terms. Our first term here and our last term here. All right, let's square the first term. FOIL it out. In squaring a radical, the radical is simply going to drop off. So we get x plus 9. And let me go ahead and square that last term. The last term is 2. We'll put it over here. It's going to be plus 2 times 2 is 4. The outer and the inner terms we get by multiplying these two together. So we have 2 times the square root of x plus 9 plus another 2. 2 plus 2 is 4. So that's going to be 4 square roots of x plus 9. It looks a little bit messy, but we're going to clean it up. Let's go ahead and put together the like terms. Now, I'm going to put a circle around this or parentheses, however you want to do it, because I don't have any more radicals that I can combine with that 4 square roots of x plus 9. But I can add the 9 to the 4 and get 13. So we get x plus 13 plus 4 square roots of x plus 9 equals, and then if I move to the right side, I saved this for last because this one's simple. If you simply square this, the radical drops away and you get 2x plus 1. All right, now it's looking a lot nicer. I'm going to take these and move them over to the left by subtracting x and subtracting 13 from both sides so that we have the radical by itself on the left, and we're going to square it one more time. So I'm going to subtract x from this side and subtract 13. I'm just going to go ahead and line them up and make it a little easier to add together. Okay, this is going to be 0. So on the left, I'm left with 4 square roots of x plus 9. And on the right, I have 2x minus 1x is 1x. And I have positive 1 plus negative 13 is negative 12. All right, let's square one more time. And when I square this, 4 times 4 is 16. And then, of course, when we square that radical, it just drops away. So we get x plus 9 is equal to, now we're going to square this binomial. So let's FOIL it out again. First, I like to go ahead and square the first and last term, so I get x squared. And when you square 12, you get 144. Okay, the middle term is going to be negative 12 plus another negative 12 is negative 24x. Okay, go ahead and distribute 16 times x. and then 16 plus 9. Got a lot of algebra review in this first unit. So 16 times 9 is 144. I think. Let me try that again. 16 times 9 is 144. All right, so we've got the left and the right. Now we're going to move everything over. Let's look at that for a minute. We're going to move everything over to one side. So let me go ahead and move everything over to the left, because if I subtract that x squared right here, it's going to make it negative. So let's move everything over to this side, to the right side. So subtract 144 and subtract 16x from both sides. So I'll line these up where they go. And minus 16x. And then I'll just move up to the top. I'm going to take all of this and bring it up to the top, so don't let me lose you. Okay, so on the left-hand side, all we have left is 0. So I'm going to flip this around and put it on the right-hand side. Start showing my work, combining everything over here. And I've flipped it, and it's going to go over on the left. So I'm going to have x squared, add negative 24 plus negative 16. And that is negative 40x. And then 144 minus 144 is 0. Okay. All right, now I'm going to factor out an x. And then we have x minus 40 equals 0. Okay, set each of those factors equal to 0. So this first factor, x equals 0, is a solution. And set this equal to 0, x minus 40 equals 0. Solve for x. X is going to equal to positive 40. Substitute those back into this equation. Let me erase my work, and let's check our solutions. All right, let's start with 0. 0 plus 9 is 9. Square root of 9 is 3. I think I've got enough erased. All right, so put a 0 plus 9 under the radical is 9. So we have the square root of 9. That's equal to 3. And then we've got to add 2 to 3. So that's 5 on the left-hand side. On the right-hand side, 2 times 0 is 0. And then plus 1 is 1. And we get the square root of 1, which is 1. Now that's not true. So we've got to toss this solution out. Now we're going to try 40. And when you put 40 in, so let me erase that, or it's going to get too messy to tell what we're doing. The only thing that we have left to do here is check that solution. All right, so there we go. Clear up the board. And put a 40 plus 9 under the radical. That's 49. Square root of 49. If it comes out nice and even, then I'm going to use it. If it doesn't, then it's approximating. And I don't want to use an approximation. So the square root of 49 is 7. And then we have to add that 2. So 7 plus 2, got a lot of 9s here, is 9. So if that's equal to whatever the right-hand side is, when I put 40 in here, 40 times 2 is 80. 80 plus 1, and that's all under the radical, is 81. What is the square root of 81? Square root of 81. I put that in my calculator, hit the square root button, and I get 9. So 9 is equal to 9. So x equals to 40 is our only solution out of those two. All right, question number 6. What is the graph of the function f of x equals, our numerator is 2x plus 2, and our denominator is x squared plus x minus 2. All right, the first thing that we need to do is factor that denominator. So however you're going to factor it, it factors into, what are the factors of negative 2 that add to positive 1? It's going to be x plus 2 times x minus 1. Okay, so I look at the denominator first because we're going to have asymptotes or holes in our graph. We're not going to have any x that we can substitute in to make that true because division by 0 is undefined. All right, so we set x plus 2 equal to 0. And we solve for x and we get x equals negative 2. Okay, so now I'm going to take that before I do anything else. I know I have another root to look at or another solution, and I'm going to eliminate any of the graphs where there is anything at x equals negative 2. So they're so tiny. All right, this is negative 1, and this is negative 2. Now it's not crossing the x-axis, so we've got to see where it's actually touching the x-axis at negative 2. So that would be okay. Let me get my laser pointer instead of drawing. All right, so negative 2, it touches, or it looks like it touches right there. So I'm a little suspect. Negative 2 right here, we have an asymptote. So this looks pretty good to me right here. Okay, at negative 2, this is negative 1. Negative 2, we have a hole at negative 1, but not at negative 2. So this is out. Negative 2, if we draw a vertical line right there, that's out. Negative 2, this is out. So this is the only one that would allow a hole, or would have a hole at negative 2 or a vertical asymptote. And then we look at x minus 1, set that equal to 0. So again, the same thing at positive 1. So look at positive 1. We have, if we draw a vertical line right here, these graphs are approaching that vertical line but never touching. They'll never touch. So we've eliminated everything except the third graph. All right, also, we can substitute in 0 and solve for the y-intercept. It gives us more information as we're looking for our graph. All right, so if you put in, I'm just going to do this, we don't really have to because we've eliminated the other three. 0 times 2 is 0 plus 2 is 2. Let me get my pen out so I can write that down and don't forget. All right, so if we put in a 0 for x, we get 0 times 2 is 0 plus 2 is positive 2. Put a 0 here and square it, we get 0 plus 0 is 0, minus 2 is negative 2. All right, so when we substitute 0 for x, that's where it crosses the y-axis. So y is going to equal to negative 1. So if we look at our graph, and that looks like that could be negative 1. So that's where it crosses, because this looks like 5, I think. So this looks like this is, again, another check to make sure that's correct. All right, what is the graph of this function? Okay, so again, I'm going to look at where we would have a hole. So look at the denominator. So at x equals 2, let's go through that same process. So here's 2. Draw the vertical line up, and this is out because we have something right here on our graph. We have a y. So we're going to have nothing. Draw this vertical asymptote here. So this could be a plus. Okay, and again, we're looking at 2. So again, this is out. and 2, and this is out. So again, that was very quick to isolate this. Again, we could put in 0 for x and see where it crosses the y-axis, just as another check. So y would equal to -1 over -2 or positive 1/2. So let's see if it, oh, I forgot. Positive 1/2 plus 3. Forgot to add that 3. Starting to get worried there. So that would be 3 and 1/2. So yes, that's where it crosses the y-axis. All right, let's move on. What are the coordinates of the hole in the graph? So what we're going to do is we're going to factor the numerator, which this is already factored, and factor the denominator, which this is already factored, so that's good news. And we're going to take out what they have in common. So they have in common the x minus 1. So let's see what x minus 1 is when we set that equal to 0. So that would be 1. So once we've taken that out and we've set that equal to 0 and solve for x, we're going to put it back into our function, our simplified function. So it's going to be 4 times 1 over 1 plus 1. So that's going to be 4 over 2 or 2. So when x is 1, y is 2. That's where the hole in the graph is. All right, another word problem. Now we know, so let's just slow down and read it and evaluate and put in those words, translate that into math, and put in our answers. So Liz needs to determine whether x plus 3 is a factor of the function f of x equals negative 2x to the fourth minus 8x to the third minus 2x minus 63. So what we do is we take this x plus 3, set it equal to 0, solve for x, and so we're going to be using x as negative 3, and we're going to be plugging it back into this function. If we get 0, then it's a factor. It's a solution. If we get anything other than 0, it's not. Okay, meaning that if we divided it into that function, we would have a remainder. So it would not be a factor. So Liz first evaluates. What does she evaluate? She solves for x, plugs x back in. So she's evaluating f of negative 3. It looks like these are all f of negative 3. That's my mistake. Those are all correct. So this should be f of negative 3. Okay, now when we put negative 3 in, a negative to an even power is going to be even. So it's going to be 3 to the fourth power is 81 times negative 2 is negative 162. So let me just put that here. Negative 162 would be that first term. Do this carefully. Those negatives can trip us up. Minus 8 times negative 3 to the third power is negative 27. So negative 8 times negative 27. Take a minute. Let's simplify that before we move on. Negative 27 times negative 8 is positive 216. So let me erase that and put positive 216. Go slow on these. Okay, and then we're down to the third term. So negative 3 times the negative 2, which is already there, is positive 6. And then that last term is just minus 63. So now I'm going to get my calculator out, add those together. Hope I don't go too fast and trip up. and I get -3. So she concludes that x plus 3 is not a factor because all of this, when she plugs in -3, f of -3 is going to be -3. So -3 goes in right here. The second line is not because we didn't get 0. All right, number 10, what is the end behavior? Now again, really big hint all through this unit is to find out where the ICANN is. Find out where the end behavior notes are and include them in your notes so you can just look this up quickly. But let's go through what we've learned and practiced. So look at this is in standard form. This is degree 3, so it's odd, and the leading coefficient is negative. So first of all, we know it's going to look like this. It's a cubic, but that negative is going to change it to this. So as x approaches negative infinity, so we look on the axis, and what we're doing is we're going from 0, we're going in this direction. Okay, so remember, this is what the end behavior is going to look like. So it's going to be going up in this quadrant, down in this quadrant. So as x approaches negative infinity, what happens to the y? It's going to positive infinity. We don't write the positive, we just write infinity. So f of x approaches positive infinity. Okay, so that's going to go here. You'll be able to drag these in on your test. Now let's look at what happens on the other side as x is going in this direction. F of x is going to negative infinity. It's going down. Okay. Oh, I did that wrong. Hold on. I went into a totally different problem. Let me get my eraser. All right, let's go underneath. So as x approaches positive infinity, f of x is approaching negative infinity. Okay, so that goes right here. I'm going to change my pen color and we'll go on to the next one. Okay, so in this one, again, we have an odd and then we have a positive. So it's going to be this, it's going to look like this. So as x approaches positive infinity, y approaches positive. And as x approaches negative infinity, y approaches negative infinity. See if we can write that up here. As x approaches negative infinity, so that's going in this direction, f of x is going to approach negative infinity. Now as x approaches positive infinity, f of x approaches positive infinity. This can get confusing. I do understand. So use your notes on your test. Yes, you can use your notes and your calculator. All right, what is the domain of the function? That means the domain is everything that x can be. So we're still doing the same thing that you saw before. So the first thing that we need to do is factor. So if we factor this, we're going to get 2x plus 3 and x plus 4. The numerator is already factored. So let's look at any problems with our graphs, any holes, any asymptotes. All right, set each of the factors in the denominator equal to 0. So I'll start with 2x plus 3 equals 0, and I'll solve for x. So we'll subtract 3 from both sides, and we get 2x equals -3 by subtracting 3. And then divide by 2, and you get x is equal to -3/2. All right, we're going to do the same thing for this one. This one's going to be a lot easier. X plus 4 equals 0. Subtract 4 from both sides. X equals negative 4. All right, so we have these two points that we're looking at, and we know that if those are equal to 0, we're going to have holes or asymptotes. So we're going to put those numbers on a number line. Okay, so I'm just going to quickly sketch this. This is 0. If this is 1 and this is 2, this would be negative 1/2, negative 2/2, negative 3/2. Okay, now let's go to the right of 0. I don't know why I circled that in because that's not going to be part of our graph, just so I wouldn't lose where 0 is. We're going to go to negative 4. So we're going to keep going in this direction. Negative 4 is going to be here somewhere. Okay, so we have these 2 points where we're going to have holes. So a circle, remember we cannot have any solutions there. Open those, open circle, and then again we have 3 areas. So I'm going to just draw a line, and there's section 1, section 2, and section 3. So I'm going to start here with 0 and plug it in and see if I have a true, if I have something that's true. So put 0 minus 4. Okay, that's negative 4 over 0. So f of 0 equals 0 times, 0 squared is 0. 0 times 2 is 0. If I put a 0 here times negative 5, that's 0. And then all I'm left with is negative 12. All right, I don't even think I have to do that. I'm listening to my cats in the background and I'm not paying attention like I should. This is not an equation. Don't need to solve for anything. I just need to see what can x be, okay, and what can it not be. We know it cannot be negative 4, and it cannot be negative 3/2, but it can be anything else. Anything else, okay? So how do I write that in set notation? All right, I write it by saying we start at negative infinity, and we go up to negative 4. Okay, but there's a hole there, so make that a soft bracket. Okay, and then a union symbol. We start at negative 4 again, and we go up to negative 3/2. Okay, not a hard bracket because we don't include negative 3/2. And I've run out of room. Union symbol again, and the last part is negative 3/2 to positive infinity. All right, so that is our solution. That's the domain, not the solution, the domain, anything that x can be. All right, now we're asked to graph the solution. So what we need to do is we need to get rid of this radical. So we need to square both sides. Okay, if you decide to divide by 4, you're going to have to remember to flip that radical. All right, I'm going to start with dividing both sides by negative 4. I am going to do it this way, but if you divide by negative, you've got to remember to change the direction of your inequality. So this is going to be greater than. So we're going to have the square root of x minus 3. Because we divided by negative 4, we flip that symbol, and negative 8 divided by negative 4 is positive 2. Now square both sides and you get x minus 3 is greater than square 2, and you get 4. And then add 3 to both sides, and you get x is greater than 7. Not equal to, greater than. So you'll draw an open circle here, and then graph, shade everything in to the right. All right, CC determines the remainder of 5x to the 32nd power minus 3x to the 15th minus 11x squared plus 12 over x minus 1 using the remainder theorem. I love the remainder theorem. It's quick and easy. So we're asking to put into words, how does she proceed to the correct answer? So she'll take x plus 1 and she'll solve for x. Set that equal to 0. Okay, so she'll solve, and x is going to equal to -1. She'll take this and she'll substitute in to the numerator everywhere there's an x. So if you have a negative to a even power, that's going to be a positive 1. So positive 1 times 5 is 5. If you have a -1 to an odd power, you're going to get a negative. So a negative times -1 times -3 is positive 3. If you have a -1 to an even power, it's a positive 1 times a -11. It's going to be a -11. And then plus 12. Over, remember, we don't have to look at the denominator. That was going to give us 0. Okay, we're just going to look at this, and that will tell us what our remainder is. So add that together. 5 plus 3 minus 11 plus 12 is 9. Okay, so when she simplifies this, she's going to first of all take the denominator, take the divisor, what she's dividing into the numerator, set that equal to 0 and solve for x. And then she's going to find f of x, which is -1. If you get 0, you know that that is a factor. If you get anything other than 0, you have a remainder. In this case, we got 9. Okay? So she concludes that x plus 1 is not a solution. So we're taking what we've been doing in math and we're putting it into words. All right, we're almost done. 2 more. What are the roots of the equation? Now you're going to be given several to choose from. So what you do essentially is take those numbers and plug them in and see if you get 0, just kind of like what we did before, because you can have imaginary numbers. So I'm going to go through this quickly, and I'm going to say let's try -6, just to give you an example. I won't go through all of these. -6 to the 4th power. Anything to an even power is going to take care of that negative. So let me do that again. 6 times 6 is 36. All right, so -6 to the 4th power is 1,296. Minus, this is going to be -6 to the 3rd power. So it's going to be -216 times -3. That's positive 648. Using your calculator, I'm not going to be able to demonstrate that here, but using your calculator, I highly recommend it. Okay, and then we have -6 squared is going to give us positive 36 times 8 is 288 plus 12. And when we add all those together, if we get anything other than 0, it's not a solution. So 1296 minus 648 plus 288 plus 12. So that's not a solution. All right, 6 is just positive 6. We'll get 0, and some of these imaginary numbers we will as well. All right, I believe this one is our last one. What is the equation of the slant asymptote? Not all of these will have slant asymptotes. Not every function has an oblique or slant asymptote. If the degree of the numerator is exactly 1 degree more than the degree of the denominator, then the function f of x will have an oblique or slant asymptote. Knowing if there's a slant asymptote is just half the battle. Now let's find out what it is. So you must use the long division algorithm to divide. So we're going to take x squared, trying to decide where I'll have more room. Let me start on the bottom here. So x squared plus 5, we're going to divide that into 2x to the third plus x squared plus 11x plus 5. All right, so we're going to look and see what we need to multiply that first term by to get 2x to the third. So I know I need to multiply by 2 and another x. Okay, first I forgot to look, but let me check. X to the third, x squared, x to the first power, and 5. So I don't have any missing terms. I don't need to worry about zeros, so that's good. All right, so 2x times x squared is 2x to the third. So we're going to line this number up over our x's. So it's going to go down here. Okay, let's go ahead and multiply both terms. Don't forget that second term. 2x times 5 is 10x, but it doesn't go underneath the x squareds. It goes here. Put a 0 there if you need to put anything. All right, and then draw a line. Change everything to its opposite. That's going to be minus 2x to the third and minus 10x. So these two should add to 0, so you won't have anything to bring down. X squared plus 0x squared is 1x squared. Bring that down. And then 11x minus 10x is 1x. Just going to write that as x. Plus, and bring down the last term. Okay, now let's look at this, and let's look at this. What do you multiply x squared by to get x squared? You multiply it by 1. That makes sense because we're at the end, and this should line up over a constant. All right, multiply 1 times x squared. Line this up. 1 times 5, line this up. And subtract. I don't need to finish that up. Here's my slant asymptote. Whatever we get here, you don't need to worry about the remainder. So the equation of y equals 2x plus 1 is our slant asymptote. All right, the next steps, finish any course materials for Unit 1. Not just looking at your plan, go into the course content, go through the instruct, go through the practice. Schedule help sessions or drop in during office hours. Take your first attempt on your Unit 1 test that's due on Wednesday at midnight. Come to Help Lab if you don't get the grade that you want after the first attempt. We'll clear up any mistakes. After correcting those mistakes and taking the second attempt, if your grade is still not passing, that's when you can do test corrections. But you have to come and see me to get help before you just automatically jump to test corrections. I'll explain how that works and how to get those things turned in. The Part 2 test corrections, you can do those multiple times. Just remember we have a cutoff date, October 16th. Read my feedback and resubmit. All right, follow those steps and I know you'll do great. So before you leave, if you're doing live class, complete the exit ticket. If you're watching later or you're in the Flex program, complete the exit ticket by scanning the code in. All right, good luck and let me know if you need help.